Okay. Quick rundown. I'm using some old ASRock X360 board that used to be my motherboard before I upgraded, and a Ryzen 3200G, which is in the Picasso family. I'm not really set in stone on that particular hardware. It just happens to be what I have to tinker with, you know? I would say it's probably about 80% functional right now. There's some things I haven't
What
been able
does
to
it
test.
mean? What does it mean? Like, tell us what does
That
it
means
mean?
there's only 80% to go then, right?
Yeah, it's getting there. Let's see. First off, it actually runs the core boot side of things. It passes both of the FSP binaries. It can run. I've tried CBIOS and EDK2 payloads. They both work in the sense that they can, find and boot a system. But there's like a few things that need some serious work before it's actually done on this particular hardware thing. I'm not sure if it's where the issue arises, if it's in code that we can control, as in, the core boot side of things, or the FSP side of things, which, I don't really have access to except for popping it open in Ghidra and hoping. But it can boot from USB, assuming that those USB ports are one of the ones that are coming straight from the CPU, not one of the ones off the chipset. And it can boot from SATA, and it can also boot from the NVMe that's coming off of the chipset. What does not work as far as boot sources are chipset USB ports and the NVMe that comes straight from the CPU. I think there's some things that need to be done there because it could do either SATA or NVMe, depending on the state of a few GPIOs that I had to, boot the stock firmware and check each time with a different kind of device plugged in, basically.
Aren't similar problems like faced by coreboot or? I thought that was the problem of having like full or Project X, or what was that like? I don't know.
Coreboot right now, it doesn't support anything x86, but the old commits are there.
Maybe Project X. Maybe I'm confused things. I'm pretty sure that was this problem of getting pretty far but unable to initialize anything advanced on the.
I'm pretty sure if Project X is what I'm thinking of, which is basically, no FSP, then yes, that's definitely a problem because the FSP is what initializes the fun stuff. Before I got the platform descriptors and such working, I didn't really have any fun stuff available. All I had was like the PCIe devices that are built into the CPU, SOAK, whatever. You need to configure the platform descriptors, which is done in the core boot side as a kind of a big old struct, and on that gets fed into the FSP side. I think it's the silicon init one. And what that does is it'll turn on various, things like the link between the CPU and the chipset. That's handled by that. The big GPU, what do you call that? PCIe slot. That's handled by that. The NVMe slot's also handled by that. So I'm assuming that's probably correct if Project X wasn't using something like an FSP, because you'd have to have code to initialize that. In fact, that was how I got around to it, to the point where I got, because like I just passed through empty platform descriptors just to make it do its thing, but I had to come back later and actually fill things in. The biggest pain point right now on this is that it boots Linux and it does perfectly fine up to a certain point, and then it just creeps, just slows to a crawl. And I'm not sure if that's something that's happening in the FSP, because I know that there's like got to be, how do you say, compilation parameters you can pass to it or something. Because like I was comparing the EFI modules from the vendor firmware to the EFI modules in the FSP. And you could tell it's a very similar code path, maybe what I was comparing to differs a little bit from the FSP provided one, but you could tell they're definitely largely based on the same code base. But like I have to modify the FSPM to even get past it, because it's got a hard coded check for 3 different basically some sort of CPU ID struct, which includes the family and the package type, and it's hard coded for FP5, which is the soldered on mobile package. So I had to modify the FSP to turn those structs to work for the AM4 package instead. But that one pain point's the big thing, because that's going to be what kind of like prevents me from working a little bit faster on the other things. Because like I think that's probably like about 10% of the rest of it. Because like all this after that needs to be done is getting the iGPU to work, which I don't think is that big of a deal, but it's kind of hard to test for the same reason as because of the slow boot. Because the build flash boot process, it's so dang slow. It's really hard to deal with. The other issue is, like I said, the chipset USB ports do not currently work, but that's because
but the slowliness, like what's the
I'm not sure why it's slow. I did discover by chance that if I were to unplug and replug a USB device, it will kind of like nudge it a little bit along. And if I do that, like, I don't know, 100 times in a row, it'll finish boot. And once it's booted, and done, it doesn't. I mean, like, I'm only in over
some
I'm only
some unhandled interrupts or something.
I don't know, because like I checked the interrupts between both of them, between vendor and mine, and they don't look all that crazy. I posted it to the coreboot mailing list, and how do you say? The coreboot mailing list, and I was like, hey, this is my problem. I'm really not sure what the deal is, because like it just looks like it should work. I've got an interrupt handler for all the links. Or not interrupt handler, the PRQ table, that thing. I mean, like, I can't see what the deal is.
I see Daniel, like Daniel dealt with little with these topics. Daniel, you were involved in Project X, yeah, if I recall correctly.
Yeah, Daniel was. Oh, I didn't realize that y'all had coreboot with NDA stuff in it. Gotcha. Huh. Because like I said, I'm not sure if this is an issue that's arising from the coreboot code side of thing, or if it's the how do you call it, the somewhere in the FSP. And because the FSP is binary, well, it's really hard to find things,
Yeah, so the point in this situation should be, I don't know if you have anything to share, because I would like to share at least my screen with the with this I discussed, and maybe that's not very accurate. So because like essentially this is not very accurate, because we don't really know what will happen and what's the plan. But I will tell you like this: like my story with FSP from Intel, and maybe other way. This is not exactly my story, because initial story was like that. Okay, there were FSP, nobody had access to source code. Maybe Google had, I don't know. But then people started to have like some issues with this FSP, so there was demand for debug version. Yeah.
Mm-hmm.
And at some people get that, some people didn't get that. So I guess that's the lowest node denominator of working in community. Yeah, Daniel.
Hey, yeah, great to be here again, and thank
you.
So yeah, I can drop a few comments on the efforts in coreboot and what you just called Project X. I think that might have been just the wording used by Phoronix, but I'm not entirely sure. So
this was name used by Ron. This was name used by Ron, and they just adapted that and spread the word. Good marketing word.
Yeah, I guess that was how he named it in the public. So there was an internal project at Google and some others maybe that was called coreboot. So that was a repository that I couldn't access either. And they, tried to come up with patches that we could then upstream to coreboot to get the initial support for the modern AMD platforms. And they were using a reference board, which is also known as Ethanol. yeah, people familiar with AMD stuff might know about it. Milan, no, that was actually a Rome back then. Milan came later. Yes.
Yeah.
So yeah, I could take that code that Run wrote, and I could run that on a Picasso. That was a 3400G, so one with, as Marty said, an iGPU or internal GPU, right? So there are also SoCs without a GPU, where if you wanted to have graphics, you would need some PCIe card or something. So yeah, the story was then we got stuck at some point where we couldn't really figure out how to initialize the PCI Express bus, and we didn't get interrupts. And that is what I just wrote essentially. And it might be that you were just running into the same issue, Marty. I'm not sure.
Yeah, that sounds similar. But the point is, Daniel, did anyone exercise the path of gaining the at least debug version of the, like, it was without FSP, so there was no debug version, yeah?
Yeah, exactly. So we were just literally running our own code on the x86 cores, nothing else.
Okay. But then I remember the kind of rant from Ron about lack of documentation for that the progress is stopped because of lack of documentation.
Yes, that is because there is no public documentation on the PCIe in it that we would need. So, there is apparently some magic numbers that you need to write into some magic registers in order to, turn something on. So, you would need to win the lottery in order to find that by chance. Yeah, I guess that is in part now baked into something that is used by coreboot, but I haven't really looked into that at all, so I cannot really tell. At some point, we just dropped the x86 efforts and hopped over to RISC-V.
Yeah, I know.
Is that how you're supposed to say it? I've never heard RISC-V said aloud before, so is that how you're supposed to say it?
Yeah, yes. It is. So
okay.
It's not RISC-V.
Never RISC-V. If you're saying yes. RISC-V, you are considered noob.
It is.
Well,
it is
I am a noob.
RISC-V, like the Roman number 5. I think they also write it on the website. It's not to be confused with
R5 or Vision 5.
Yeah, the same like say coreboot with capital C.
Yes,
try to say it.
if Michael from Forenix hears us, Orboot and coreboot with lowercase. Thank you. Anyway.
Yeah, but that's his way of saying that he's essentially outside of this.
Anyway,
but yeah, because of the basically the really slow boot part of the build flash boot process, for testing things, it basically kind of like it's preventing me from doing the other stuff that needs to be done on this machine, because like this is basically a linchpin. Because once I can do this bit, I can probably figure out the chipset's USB ports, because like there's an individual that I know from the Talos 2 project who was doing a lot of work on as media based devices because there's apparently some sort of bug that was occurring on Talos 2s, and it turns out that the firmware that's loaded into this chipset on AMD devices is basically the same thing, and the code paths, if you dig into the vendor firmware modules, it's basically the same. And we already have a firmware loader that's either what we need or very close to it in both the Linux kernel and the U-boot source for the Asahi Linux project. Oh, X570 is not as media. Okay. But yeah, so like that part, it's just like you just have to crib it over, I guess. But like I said, because the process is so slow, it's kind of, it is what it is, Yeah,
I understand that the alternative would be, like I said, like my kind of experience and like terrible memory is like the story was, okay, you cannot give me source code, just give me debug binary. Yeah. And like without, like, let's say debug binary without allowing redistribution, for example. Like some like minimal step that may move things forward. And on the other side, I kind of like, as we discussed directly on DM, I kind of would envision a situation in which 3MDEP engage in this development. Although I'm not sure, like as you said, this ASRock X370
Nobody wants that.
is
So
probably
that
not
we
good
just compiled
target
them.
for
And
that.
if two, yeah, there is
But
some
other targets, I don't know. Like, so is AM4 a good target?
I think it's still kind of popular, especially since they just released some stuff to, I forget what it's called, but it's the GPU AI thing that AMD has, ROCm, so that you can do it on the iGPU and use the system memory instead of the VRAM on a discrete graphics card. So I don't think
finally did that.
I know I've read about it. I'm not sure if it's quite public yet, but I know that it's a thing that's happening.
Yes, it is. It's out in one chipset, but server at the moment.
Gotcha.
I guess they announced that, like, either they announced that publicly.
So I don't think it's quite
AI accelerator, like top AI accelerator or something like that yesterday or something.
I don't know when I saw and what I saw, but I do remember that was the gist of it.
Okay, so just to get back on track with the what can be done. So one thing is this AMD FSP debug version, and this should be easy to do. This should be very easy to do. Just like we have to just knock correct doors. I didn't get any reply for my inquiries to Marshall and Matt. Maybe at some point we should invite Matt, Mr. Chromebox here. I have to think about that. Like, he always was very rational about, for example, presence of Dasharo on Reddit or something. Yeah. So I guess like I have to ask him if he would be able, for example, to join next vPub. But so that's one thing. The other thing is I really doubt we can get access to the source code of AMD FSP. Mostly because it sounds like it was done for Google, and as it was discussed like between Intel and Microsoft, then probably this relation, like, we cannot enter that relation and do anything meaningful for some old code which is considered experiment and so on. But on the other side, the AGISA path, but on, like, this is also convoluted and problematic because AGISA is completely not prepared for working with coreboot, and coreboot is not prepared to work with AGISA. AGISA is like full of EDK2 like interfaces. So essentially, it would be a lot of work, and we started to do that work. And what Zirblazer mentioned, what was mentioned in this article of Phoronix, that 3MDEP will work on AMD because we planned to publish that code, but essentially we didn't. But what we did, unfortunately, was in EDK2. So, and I probably can find this presentation. I don't remember the model of processor. I don't know, maybe Mitchell remember. This was like V2000 or R2000. I don't know.
VR1000 series. So these were the very first Ryzen embedded series SoCs.
Yeah. So we started to develop the kind of way of interacting with AGISA from EDK2.
I mean,
But
like,
what's the benefit of that path? The benefit of that path is that 3MDEP could build the debug version of AGISA.
Yeah.
And I doubt we can publish that without any without having, for example, hardware in our shop, or for example, having internal projects with the goal of having hardware in our shop, for example, or with the goal of having hardware in our partner shop. But if we have this kind of project, I guess we could do that, and that would definitely give you different ability to like move the project forward.
Yeah, there is that. With regards to debug builds and debug Agisa and such, I got a little fortunate in myself, so I actually do have kind of a debug build already. A very, very limited debug, and I still need to fiddle some things out with it. But in the vendor firmware, the debug output is actually kind of simple. All it is to just search for a PAIM-to-PAIM interface by a certain GUID and calls the function from it. I was able to actually build a simple module in EDK2 and insert it into my firmware. That's how I even got the PCI devices that I have online. Is because
You showed that last time, I guess. Like you showed that last time, yeah.
I think I did. So I'm not sure what else more information could be gained from this, but there, if nothing else, it would be maybe a little bit easier to deal with because for some reason, and I'm not sure exactly why, because the code that's inserted is very simple, but maybe it's got to do with like the firmware expects a particular layout, and by moving modules around, I break it. But at some point, with that module installed into the firmware and flash and whatnot, it just locks up. And I was able to get enough out of it to like I said, turn on the whatever that stuff, the PCI devices. There's like 3 of them that needed that: the NVMe, the chipset link, and the main PCI port you'd put a GPU in. But I mean, yeah. One thing that would be really helpful, I guess, is because like certain firmware versions, they seem to behave worse when modified in that way. Would be able to like just be able to query the machine for its platform descriptors, but I have no idea if that's even possible because it tells the machine the platform descriptors, but I don't know if like it's stored somewhere in a retrievable format after that.
I guess that would be question to someone who played played a lot with AMD. I guess like AMD is kind of blocked on the path to open source firmware because of this magic initialization sequence required for high speed interfaces.
So like it could be something incredibly stupid. Like I said, I did a little bit of serializing on it, and nothing in there actually jumps out.
So the way to resolve that is of course to have more people looking at that. So and the way to make more people looking at that is making it very easy to look at it. I guess like you already created kind of convoluted environment for developing the.
I mean, like doing the serializing isn't really that hard. I do need to like. I mean, like it's not hard given a certain circumstance because I just happened to be lucky that the firmware version that I was, basically trying to pick apart, it looks like a regular BIOS. So the reset vector is at the end of the flash, and there's no weird compression things going on. But later versions started using some compressed tech that does weird stuff. Yes. I mean, like, yeah. I mean, like, the RGB controller was a stupid thing, but once it was figured out, I guess, that was a thing. Because, like, it could turn off the machine. If anybody doesn't know, the RGB controller on this gaming motherboard, yada, yada, it could turn off the whole machine if it's not initialized within, like, 10 seconds. So, yeah.
Similar things occur like on Dell laptops. If you do not send some kind of command to EC in like 30 seconds, it just shuts down.
Yeah, I mean, like the module inside the firmware that controls the RGB controller is called EC8051. So I guess it's kind of acting in that fashion. Yeah.
Mm-hmm.
I mean, like honestly, like if we could just get a one answer from someone at AMD that actually could answer it, like, hey, why does this slow down here? That would be like killer. But unfortunately, dealing with companies, sometimes it's not that easy.
Yeah, I recall using Serialize like a few years ago when I was porting Dell Optiplex, but I haven't had so much luck as you. What I was trying to use it for was to trace the I/O traffic to the Super I/O, but like it was stuck very, very early in the.
The problem is, I guess, like we don't know right now even what we're looking for. Yeah, like because like this is like magic initialization sequence. Like someone claiming that it's it. Maybe like Marty say that it may be some mistake. So yeah, I guess the one path is just like making it easy. So the problem is, so can we kind of calculate what's the lowest possible price for setting that up? Like
You mean the exact hardware setup I have?
I'm not sure if that's good direction, because maybe you have hardware setup which you choose because you want to do something extensive. Maybe
Well,
there is a way of doing the same, like having the same capabilities from the coreboot development perspective, but paying way less.
yeah. Let's see. The main issue with AM4 is even managed to get Picasso working. The CPU support is 32 for there. Yeah. It's something that came up because I came to the standstill here, and I forget which one of it was, but it was one of the AMD people that hang out in coreboot. They told me that the Picasso FSP was the first one they did, so it has they had never done it before, so the first time. So there was like possibly issues at the time. And so I went ahead and got a 5300G, and that one, which is in the Cezanne family, it basically cannot be used as of right now with the provided PSP binaries. Mr. Chromebox, I forget his actual name offhand. He's the Matt. I sent an email to the people who ran the binary repository, and like, hey, I did this with Picasso, got to this point. Well, because it stalled out, I was thinking because they had mentioned that was the first FSP, there might be issues there that they may never have tested for, because who's testing for AM4 when you're building for mobile. So I got a Cezanne's APU and tried that, and it like literally does nothing, not even a single byte over the postcodes or anything of that nature. Nothing happened at all, except that it boot looped because the RGB controller was not getting its initialization sequence, so it was doing that much at the very least. But so I sent them an email, and they told me, yeah, the Cezanne PSP blob situation is worse than Picasso, because the Cezanne PSP blobs only support soldered mem, only supports certain Google specific things. There's a lot of issues, in other words. I'm not sure how many of the supported soaks in the coreboot tree may or may not have this problem. But yeah, I mean, like I mentioned right at the beginning of this, I'm not really set on this particular piece of hardware. It just happens to be what I had on hand to tinker. So if you've got something that is more available, maybe even more affordable, that we should focus on instead, I'm fine with that. It's just I got to start somewhere.
Mm-hmm. So of course, looking at that, it's like ideally it would be if we can identify target, which is like close enough to others, so others can benefit.
Yeah.
So you see that it can be even bought for $32. So then the question is like how much for CPU and how much like minimal memory we need.
Well,
Yeah, but that's CPU. What is
Yeah.
this, like Athlon Pro 300G? What is this?
The 3200G is an actual Ryzen
So,
CPU. It's Picasso.
Yeah,
Okay.
the 300G, the Pro 300GE is not the same as the standard 300GE. They are the standard 300G, I think, is either Raven Ridge or I forget, but the Pro 300G is I'm not mistaken, the first Picasso APU to be released, except that it was not released to the general public, and it was only for a select business class pre-builts that were for specific use cases.
I love this. Makes sense. Like
That's
has
why I
to
said
be-
specific use cases. It was
Ah.
an extremely tiny launch.
Mhm.
I remember there were a few. Even those models, even those OEM pre-builts, it was a very, very, very limited list of the models, and very limited availability of those.
I think in 2019, when I was looking for cheap AMD hardware that would do trench boot, I'm trying to remember which model. It was like, I think Daniel was working on it. There's a square. There's an
Up
there's
square? Up square?
Huh?
Up square?
No, not up squared. It's fuck. It's $150. It's the cheapest model that will run a desktop. You know.
Hey, you mean the A300?
Yes, the A300. Thank you.
Yep.
So that's the one. That was the cheapest one. And then I wanted the lowest power config, and it was that same one you just mentioned, the APU with a Pro designation, and you were able to get it from eBay. Like eBay, somebody in China would just send it to you. So that was
A300 is AM4, yeah. So that's the
well. There's a few generations of that line. So you can get a newer 310 or whatever 320 it is now. You can get a newer model that has
that one.
Yep.
Yes.
So that was pretty cheap, I think, as a motherboard, as a all-in-one. Right, exactly. Daniel was working on it. There you go. So he did a 3400G.
Yep. Also,
I personally was searching for a 300G back, starting from when it was announced. Again, very limited announcement even. But I started looking on AliExpress back then because I wanted to upgrade my grandmother's PC from the 200GE just for wider memory compatibility. Just that.
But is it this A300, Daniel, that ended up also with the same issues like?
Yes. Yeah, well, same or similar or related. Yep.
So maybe Rich, you have some ideas how to attack this. I know that you will also probably turn that into do not do this because this is shitty project idea. But if you will have to deal, like, the problem is, of course, like, there is this magic sequence somewhere. Documentation is not available. AMD probably will not release the documentation, even if we will try hard. There is this AMD FSP, which could, like, debug version could reveal some additional information. There is this ability from 3MDev because we are AGISA licensee, so we could do something from this side. For example, like putting on our roadmap a project based on AM4, and because we can ship Dasharo with AGISA for that hardware, we maybe could enable some adoption here.
Right. So let me just ask the question I was going to ask, which is what happened to OpenSIL? I mean, shouldn't you be focusing on that?
Well, I would gladly
Maybe.
focus on OpenSIL, but it's very hard to take a binary and translate it to source code without some sort of
I have been
documentation.
told, or at
Why?
least what
Source
I've
code
read.
of OpenSIL is available. What you mean?
Well, OpenSil is available for one specific kind of processor. It's going to be different for each one for the most part. I forget the exact one, but the one that they call Onyx now. The OpenSil code for, say, Raven Ridge would be different from that one because they are fundamentally different on a number of levels. Otherwise, we would only need one FSP.
So what I've read, I don't know if this is wrong, but what I've read is that AMD plans for OpenSil to replace all of the others.
Yes, it will.
And therefore, yes, by 2026, which means, but the point being that all of these issues are going to go away on their own. Like all we have to do is wait. This issue is gonna solve itself.
And that's the most famous, like Daniel, like that's the most famous blockade of the open source development.
Well, okay.
No, I'm not saying to wait. Okay, absolutely not wait.
I'm asking from an ROI perspective.
Take what they gave you and beat on it. Jump up and down and scream loudly. Okay.
I'm beating the shit out of it.
Right. So you put pressure on them to accelerate the Ryzen versions. Obviously, they're going to start with Epic because that's where the money is, right? And,
obviously.
Actually, it's not even that. It's not even where the money is. The only reason they're open sourcing in the first place is because some hyperscaler insisted on it.
Right.
So they have some large purchase. It's mandatory. Fine. But they also want the PR and all the good vibes of supporting open source. So that's why you have 2026. Now, in order to be in production in 26 on all, or not all, but many Ryzen systems, it means you got to have stuff working for new Ryzen stuff and pre-release hardware next year, probably later next year. There's also the question of CIMIC. So Intel released CIMICs, for recent generations. Does AMD do the same thing?
No.
AMD have a thing called SimTrace, which is
SimNow.
Oh, sorry, SimNow. Yes, but it's not. There's not a public release of it like there is for CIMICs.
OpenSil is developed using SimNow.
Right. So, can you try to get access to SimNow?
We can, but we can try.
And for the purpose of working with OpenSil.
Yeah. Well, I'm just. So you see that Brian told that I'm not sure if it is available in the public version because CIMIX also got the proprietary model. And I guess like that SimNow, like major of how SimNow works is proprietary model. I'm just telling that additional information how this probably work. But
CIMIX,
we will try.
CIMIX used to be entirely closed, but enough people pointed out that if they want feedback on experimental new bits of the architecture, they've got to find a way for OS developers to try it out. So the Intel releasing CIMIX on their website with QSF model and things like that is a direct consequence of finally realizing that keeping it entirely closed was harming their business, not helping.
It probably didn't hurt that they got rid of Wind River, because it was Wind River CIMIX, I think, at some point.
It still is, and they've spun it out. They spun Wind River out. They haven't got rid of it.
Mm-hmm.
Well, I just mean that there's no Intel. Like a Wind River was $50,000 a seat or something. The CIMIX original price was very high, I thought.
Yeah, the original license for CIMIX was something obscene.
Yeah, so the new owner of Wind River is in automotive, and they probably don't care about that. So.
Oh hey, That small form factor link is actually kind of cool.
Yeah, that's the smallest thing that's not, that it can fit a couple of NVMe drives and an actual cooler. So it's a very weird little box.
It also attaches very well to the 3M-DEP RTE. So I mean, literally, I could just connect it via USB, right? So it would be powered by the A300 itself, right? So you get the constant USB power supply. So I can connect to the RTE over network. I can reflash remotely, and I can monitor the console output remotely. So it was just perfect. A good power cycle by just attaching to one of the, pins on the RTE. It was the perfect remote testing setup, essentially.
Does it have a proper serial port, or do you have to bodge in some attachments to that?
It does. So there is a 4-pin header, and the two in the middle are the TX and RX pins of the what's it called again? The Super I/O chip, right? So the x86 would talk to the Super I/O chip using the 3F8 port, and then the Super I/O would just convert it to something UART, right? So, yeah.
Yeah, it's just a standard header. You can stick it'll come out in a 9-pin
Gotcha.
DB9.
Because
no. Hang on. Not the DB9 connector. There is an optional hole for a DB9 connector, but that is not for the A300. It's just because they had a similar board with a very similar case, so it sort of leaked over into that design. But you cannot use that DB9 header, the port. So there is no such port. There is a non-existent header on the main board. So there is just a bunch of solder pads, but there is nothing connected to it. It's virtually empty.
Okay, sorry, I must have misremembered.
Yeah, so you need to use the Super I/O. But thanks to that hole, which would be for the DB9 connector, you just punch it out and run wires through it. And that's how you connect the RTE without, having to have an open case.
Gotcha. I might.
Marty, like, where did you heard this story about OpenSeal? Because, like, where did you get these claims about, like, you have to write everything, like it's like major rewrite of OpenSeal to enable something else?
Well, it's not a thing that I actually read per se, but it's just a bit of common sense, in my opinion. The coreboot project, they have a separate set of FSP packages for every single AMD SOC that is currently supported by coreboot. So if you go under the projects coreboot, source, SOC, AMD, you've got Cezanne, which has its own blob, Picasso, yada yada. They all got
you should look like at the Genoa, but it doesn't matter. The point is, of course, maybe other way. I guess the challenge with OpenSeal will be also kicking correct registers, like the sequence of kicking the registers.
Yeah, I'm not saying this like major, but I know that you're going to have to write something that is incredibly specific for Picasso to get Picasso to run on OpenSeal, because it's got different registers, and you're going to have to write something different for Cezanne with OpenSeal because it's got different registers.
But our point is not, enable everything. Like, as Rich said, Stack Trust, that it's like about like putting a little bit of pressure and like kind of like they will feel this, but because I kind of leaning into direction that AMD FSP and AGISA paths can be dead, because an investment in that, if they will keep the promise, because we don't know it will happen, will be essentially like completely didn't make sense, like in 2026, if they will keep the promise.
My point isn't so much that porting everything to OpenSeal will be a pain in the ass, just that you're gonna have to do porting per soak. And again, we're only talking about the APUs themselves. Nobody's buying an X370 motherboard to stick a 3200G in it. Nobody's buying an X570 to put one of those in it. They're buying it to put the big beefy, 2700s and shit in it. You know what I mean? Nobody's buying it for that reason, and we only got FSPs for those guys anyways. Yeah, Cezanne or Vermeer. The nice ones, like the one that's sitting in my machine. I forget what family it is, but it's a 5950X, whatever that is. I had a 2700, I had a 1700. I wasn't trying to stick some rinky dinky little iGPU APU in there. Because and that's but the point I was making about porting to OpenSil is well, it's very hard to port a blob to OpenSil when you don't even know what the blob is actually doing. You don't know the data structures that are in there. You don't, there's a lot of stuff that you don't know with just a blob.
Yeah, but maybe the path that Rich trying to suggest is that 3MDep will do the OpenSil part. That's kind of a lot of work for us. I don't know if we have resources for that. At least maybe that part of the register where there is need for some additional documentation.
So look, you every day that you get up and you do something and you have work to do and you have a roadmap for the year, we know that you are always going to have more work than you can possibly do. Can we agree with that?
That's just life.
Yes.
I was going to say, what is this revelation? Can I get some more?
That's what Demi said, Irian.
So, you just don't have the budget to do work that's going to be thrown away. It just doesn't make sense because everything you do is barely moving you forward, right? It's just, why would you do something you have to throw away? Unless you had a lot of money going to be thrown at you and you're going to get 5 years of sales from that, thing, right? So it just makes no sense to work on anything else but OpenSil.
Uh-huh.
All right. Now, you've gotten lots of stuff out of AMD just by being a squeaky wheel. So why not try that? And then, because if they are going to support a lot of things by 26, they're not going to want to be sitting around in 26 with half their stuff on a GSA and half on OpenSil. They're going to want to support even the older stuff, right? Whatever's still in support, which includes embedded, and embedded has some of the, Zen 2 and Zen 1, maybe even Zen 1, right? Has 7-year life cycles.
Well, so on that specifically, they're supporting new stuff on OpenSil. They're not supporting old stuff on OpenSil. OpenSil will not work on anything prior to the first one where the PSP turned on the DRAM controllers in order to set up memory encryption.
Perfect. See, this is exactly the type of extremely important information that we need. So, and what you just said refers to a generation of EPYC, right?
I think it was Rome.
What you're saying, is happen, Andrew, you're saying that PSP doing all the DRAM initialization, it's for, I guess even this A300 had this.
Yeah, so in any AMD processor that has memory encryption, it's the PSP that does the DRAM training, the DRAM initialization, because the memory controller needs to be set up and programmed with the encryption keys prior to the main CPUs turning on.
Yeah. But
that is also why they suddenly have a far less in the way of proprietary stuff they can't actually release the source code for, because now it's moved into the PSP.
Yes, but yes, that's true, and that's true for a long time, and that was also the hope of ports for this even this Cezanne, even this older stuff.
So the reality is you'll be able to look at the OpenSil source code and have a better idea of how to do the older stuff. Because there's stuff still around normally in AMD processors that hasn't changed since the K10. Using that to see how pieces of initialization vary over time will be useful, but OpenSil itself won't actually work on anything prior. That is not an intended target.
Yep, that's fine. That's fine. But it's a starting point, and you can work backward if you want to, and if there's a need and so forth.
Yeah, I guess like considering the amount of energy that Marty put into the AMD FSP and all, like this was the last session, like he showed serial IC, like all these registers, like hours of booting, like all this stuff. Like if this energy we could put in OpenSil, like yeah, I guess like I wonder what we will have right now.
Well, so remember the primary product of hacking is a human, not code.
Yeah, that's true.
The product is the human doing the hacking. It's an upgrade of the human. So
yeah. Like we bow because this was like extremely like interesting how he approached that and what he achieved with this and with his idea about resolving those issues. Yeah, so we right now know how to approach some stuff thanks to that.
I mean, like I'm not set in stone on using the FSP, but if you're telling me that the OpenSil stuff can't be used, period, for older stuff.
So what I'm saying is that I have been told straight up by AMD they are not intending to do OpenSil on anything.
So it's
prior to right.
And of course, there's no economic reason to do that. Okay,
that's another thing. Yeah.
So basically, Andrew, just to rephrase what you're saying, is what you're saying basically that AMD is not willing to open the initialization of their DRAM controller?
AMD will be in the same position that Intel are and everyone else in that it is IP that they do not own.
Yeah. Right.
Why is that?
Because it's probably all Synopsys.
Yes.
Why is that?
Because they're doing the MRCs, the memory controllers in the world. Yeah.
Yeah.
They are leading provider of IP blocks for memory controlling.
The reason for not open sourcing it will be a straight up licensing problem. It's the same thing with arguments that happen about GPU drivers. The reason most GPU drivers aren't open is because everyone knows that if you open source it, you'll suddenly invalidate everyone else's patents.
So
it's straight up boring contract reasons, not because they have a vested interest to hide it from the open source people.
Power 11. Okay, so that means there's no. I've heard some rando on Reddit said that the reason that IBM considered doing their own DRAM controller, but wasn't able to because of COVID issues, and therefore Power 11 could change. I don't know if that's
yeah. So I guess
I don't know if that's
the
accurate.
COVID hardware, an entire generation of hardware called the COVID generation.
Let's stop. Like we should wrap up hanetzer blog because I would like to have some decision, maybe not decision, maybe like some consideration for the next Dasharo user group or vPub, and then like Andrew, Demi, you can take the stage. You can it would be great. I also will go for some drink. So, but getting back, hanetzer to you, like maybe we should collectively decide like what would be the smallest first step for OpenSteel.
Just to appreciate what you have, okay? Is there any other place on Earth where someone who has NDA access to AMD material and others who have access to Intel material and someone like hanetzer who is just raw talent and perseverance banging their head against binary blobs, okay? That all of these people are in the same community to support each other without violating any contracts, okay? Let's be clear. On a public channel, no less. All right, this is an accomplishment. So the answer is not to focus only on the NDA or only on the official stuff or only on the banging your head against the wall. It's to use the two of them together, right, from both sides.
Yes.
To ease the path. So that's
why, Rich, I'm trying to create a first task, like a first step. Like, of course, like Sim now kind of request 3MDep will try to get access to it and see what kind of convoluted agreements are related with that. But I don't know if this will succeed. The point is OpenSeal. So OpenSeal's code is open, as the name say, but it was not some time ago. But we have OpenSeal, and like, what would be the first? Like, maybe you should like compile Genoa stuff, try to run it on, and try to. There should be like basic coreboot integration because it was released with 4.22, and we just like try to run it on. Maybe that's the basic step first. I don't know more, hanetzer. Maybe you have like a better idea.
I mean, like that's kind of the idea I had. But I was wanting to ask Andrew, I want to get some clarity on what you said. You said that AMD specifically told you that they are not going to do OpenSil for anything older than what is currently in OpenSil.
But no, not quite. I think they're eventually wanting to go back to the Zen 1 Naples platform.
Okay.
So it's not Family 17, Family 19, which was a fundamental change in base architecture of the CPU from the prior generations.
Okay, so but the point is that there's no technological reason why a Picasso, for example, could not run based on OpenSil.
No technology reasons, no. But
okay,
AMD only have a finite amount of money,
and they want to make more of it, and that's understandable.
Yeah,
and finite firma resources, and also like maybe problems with publishing older stuff and so on and so on. But I guess I'm sold on the idea of OpenSeal for AM5, AM4. I don't know, like that's question. And hanetzer, the question is like, if we can, like, if you could try to run like, I don't know, maybe I don't know what's the likelihood this will be white smoke, and how much you are afraid of seeing white smoke. But I doubt it will be a white smoke, but there is always a chance. Just like trying the OpenSeal Genoa and just, trying it on the platform and see if there will be any on the serial, anything.
I mean, like, I've got words. I'm bad at talking. Yeah, I mean, like, if I'm just not sure about how the integration between coreboot and OpenSil itself works, because it's a bit of a weird situation, but I'm not opposed to, like, say, bodging in some CPU ID values into the OpenSil, but like, I have no idea how to actually go about starting that is the thing. It's because it's just as a brand new way of doing things in the coreboot world, because it uses Mesa, and it's weird.
It's weird, but the Genoa POC is public.
Yeah, but like, I have no idea how to even freaking build that at the
moment.
Just
a comment on that is that
is everything possible? Just read and analyze the code, get to know how it works, and adapt it to your case. pretty simple, right?
And intuitively follow what the hardware is doing.
Yeah. So, Michik, like very funny. The reverse engineering of AMD FSP is way easier. Or maybe reverse engineering of
Just to
really.
comment on
Yes.
on the
like,
on
I
AMD
disagree. I completely disagree.
Well, I mean,
hardware
like,
in it.
it's probably easier now because the AGISA/SSP it's UEFI, and UEFI is full of structures, and that makes certain forms of static analysis easier than, say, a flat binary blob like back in the day. So it's got that going for it. I'll give it that much.
Yeah, but OpenSeal is open source. Yeah, so like you have open source code,
but
open source OpenSeal, and there is claim that closed source AMD FSP or AGISA is easier.
No, I'm not saying that. But the thing is, you still need to poke at the closed source bit to find what you need to put into the open source bit. The people who wrote the Novo driver didn't just start writing code with ideas in their head. They had to see what the closed stuff did in order to write Novo, or Novo, the good NVIDIA driver, the open source one.